G'day nerds and nerdettes, welcome to the review part of the Geeetech I3 Pro W. Alright, all of that aside, the printer itself is pretty decent. Its recommended retail price is about $199 AU. It's a plywood build, 6mm plywood build. It comes with a up-to-date ramps board. The it's a self-developed GT 2560. The control board has space for other components like a second extruder, the 3D touch auto leveler, and a Wi-Fi module to print your prints wirelessly. Excuse me. However, these options aren't fitted to this model at the moment, so we're not going to do a review on those parts. Before I start, I'd like to point out some flaws in the design. My first and biggest issue is these vertical guide rails. They're very short in comparison to the size of the X-rail, and due to the fact of the weight of the extruder motor, there's a fair amount of weight pushing backwards on these rails. As you can see, it wobbles backwards and forwards. I don't know if you can see that in the video. Which is a bit of an issue, because when you try and lift it up for maintenance or whatever, you have to lift it exactly evenly, otherwise it catches. The linear bearings catch. A simple fix for this on Geeetech's part would simply to include a longer linear bearing, something that probably came up to here, and to attach that on this top side of the X carriage mount. Alternatively, we can print a small coupling that connects to this guide rod that comes out and hooks onto the front of this rail, so that it holds it forwards, it stops it from falling backwards. As you can see, it wobbles backwards and forwards. Now, the reason this is an issue is because the plastic rubber linings for the coupler, which are inside, for the bearing, eventually wear out. So that's a bit of a problem. The next issue, in my opinion, is the Xaxis drive rod. This is bolted to the X carriage and causes wobbles. Sorry, not Xaxis, the Xaxis drive rod. This rod originally is connected to this X carriage on this part just here. As a result, a improperly installed or a bent guide rod will make the X carriage wobble side to side. So what I've done is I've printed some upgrade parts. Another improvement would be to 3D print a Z carriage top mounting with a slightly bigger hole for the drive rod to move around in a little bit more freely. This would stop the translation of the wobble going straight into the X carriage. I haven't done those prints yet. I may do a print, install and review of that upgrade in a future video, so stay tuned. You can find links in the description for all these linear upgrades. There's a few to choose from. My recommended picks for this particular machine are in the description, so check that out, or you can look for them on Thingiverse. I spent a fair few hours building and fixing this machine. And when I finally got to do some prints with it, they were terrible. I had a lot of problems with layer adhesion. I don't know if you can see that in these parts. That part is a good example of the X carriage wobble and the misalignment between the X carriage and the Z drive shaft. Here we can see parts that are coming apart at layer level, and are really quite poorly adhered to. I mean, that shouldn't be happening with decent prints. So I maybe did a half a dozen of those before I gave up trying to print upgrade parts on this printer for itself and decided to do it on my other printer. I could have spent more time tinkering with temperature settings and gotten a PC fan and attached that as a layer cooler. But I figured it'd just be easier to print it all on my other machine, get it all installed, and then see how we go from there. Part of that issue was also the layer cooling fan. As you can see here, I've installed a 40 millimeter layer fan cooler. It's got two arms that go on each side of the cooler and blow directly onto the print surface. I don't know if you can see it from there. Try and get a nice shot from the side. There we can see one of the arms on one side of the hot end, and it blows directly onto the print bed. So that helped with layer adhesion in the end, and a slight tweak to the temperature also helped. And I finally got a print out of it, at least a decent enough quality print to show you guys. Now, you may be thinking, wow, that's pretty rough, and you know what? It is pretty rough. This was printed before I installed the layer fan, so you've got a lot of sandwiching with layers. That is also due to issues with the Xaxis rod wobble, and the fact that the linear bearings rock backwards and forwards. So a lot of those layer lines are issues with that carriage and the wobble problems. We've got a fair bit of under extrusion on some of these layers. We can see just here on the door support, we got a bit of under extrusion there. That is a temperature issue. I need to tweak the temperature slightly for that. Also in the chimney there's some issues there as well. But all in all, a first print with minor tweaks and adjustments, that's not too bad. I didn't get much better than this with my first CTC printer when I first put it together. So that's okay, considering no upgrades were done for this print. Just as a comparison, guys, this was a print done on my current printer, the one that I use the most, my CTC. We can see here both settings were the same. They're both printed at 0.2 millimeters or 2 micron height, and we can see a significant difference in the quality of the print in the layers. There's very little under extrusion, maybe a little bit up on the top here. Got a bit of stringing there, which happens. There's not much to do about that. I can tweak the hot end temperature a little bit to get rid of some of that. Maybe a bit more retraction, but the difference is noticeable, extremely noticeable with this print compared to the other. Let's try and see if that's in frame. We can see the difference. So just a quick comparison, see what you're getting out of the box. We'll do a future video showing how the print quality is improved between this print and the next benchy that we do. You should see some significant improvements between the two. Alright, so you can find links to the description. My top 2 picks for the fan. You can get a blower style fan, which is like the one I've got on my CTC. Blower style fan, which is like that. And then we've got the 40mm fan, like that one there. So links in the description to Thingiverse files, where you can download those, or you can just search for them on Thingiverse. Really, to get to a point where you can start printing decent quality parts, these are really the only 2 upgrades you need to do right away for decent quality prints. Once you've done these upgrades, you can start moving on to some cosmetic upgrades. Now, this is important, guys. The reason I'm only mentioning this now is because without the upgrades already mentioned, you won't be able to print the next upgrades. Before going any further, you have to print a shroud for your power supply. As you can see on this unit, the power supply terminals, unshielded power supply terminals, 240 volt AC power terminals are located down here at the bottom of the printer. Now, your power switch is right next to them. Your fingers are millimeters away from severe injury or even death. Please note that this unit, when I received it from Geeetech, already had the power supply mounted in this direction. On my previous builds, or my other i3 style builds, I have mounted the power supply the other way around with these terminals at the top to avoid any dangerous contact. Now, you have to remember that because it's AC power, when it's plugged in, it's live. Whether you switch the power on or not, it's live. So please be extremely careful when putting this build together. It is dangerous. The reason I have not mounted this the other way around is because the power cables or the power leads are too short for me to turn it around to make it much safer. They simply will not reach. If we have a look here in the back, you can see that there's really not much length to the cables. Here you've got the power from the supply going to the ramps board, and down here you've got your power switch going into the power supply, and that cable is only maybe 5 centimeters long. So because of that, I've not been able to turn the unit over to be in a safe orientation. Now, having said that, the installation instructions provided to me by Geeetech do state that this power supply should have its unshielded terminal connections at the top of the unit. It should not have been installed in this orientation. Regardless of all of that, regardless of whether you put it this orientation or the other way around, a shroud is still needed and should be printed as soon as possible. This takes me on to my next point. Specifically because of this reason, this printer DIY kit is not for beginners. It requires you to wire up a mains power supply, and sadly for my liking, it's not well shielded. As well as the safety concerns, there could be legal and insurance issues within Australia with regard to unlicensed people wiring up 240 volt mains to a power unit like this. So again, I say extreme care is needed when putting this kit together, and you should definitely check your code requirements in your location before you start doing this. The rest of the build is pretty simple. The rest of the wiring is self-explanatory, connecting the LCD to the ramps to all the extruders and stepper motors. It's not a real problem. The instructions are quite clear, and they've got a lot of videos showing you what you need to do. So that's all pretty good. I have to say, once I put this together and I stepped back and had a look at it, I felt a great sense of achievement. I mean, this is quite a complex build. There's quite a lot that goes into putting this together, and you do feel good when you're done. This particular build was difficult as parts were not identified in labeled bags. Some parts were missing due to poor packaging, but after using some spares I had lying around from my other printer, it all went together with no real issue. Again, I said this before, but it's pretty straightforward. Follow the instructions, watch the videos, shouldn't have too much of a problem. Once the printer is built, and you're ready to start doing your prints, you're gonna have to adjust your extruder voltage on the micropotentiometer. Your extruder is this one right here. This micropotentiometer here controls the voltage going to the extruder motor. So if you guys only turn at 1/5 of a turn at a time, so you don't overpower your stepper motor and burn it out, you can do this while it's live. Make sure you use a screwdriver that's got an insulated handle. Preferably, if you have one, use a ceramic Phillips screwdriver so you don't short the connection on the potentiometer. If you do it carefully while the printer's running, when it comes out of the box, you'll hear like a doop, 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 doop sort of sound, and that's coming from the extruder missing steps. It's not getting enough voltage up at the extruder end here to pull the filament through. So if you do that while your printer's running, as soon as that clicking, thudding sound stops, you're good to go, and you'll be able to start doing your first prints.
Does it pay to maybe check your voltages with a multimeter?
Yes, you can. To check your voltages, you've got your ground pin and you've got your VCO pin. If you put your ground multimeter black cable to this pin and your red multimeter cable to this pin, you'll be able to see your voltage level. Do not go any higher than 1.5 volts. 1.5 volts is the extreme maximum, and you'll start getting stepper motor overheating at that voltage. A good optimal sort of level is 1.1 to 1.2 volts, which should stop your stepper motor clicking. So once your stepper motor stops clunking, you're good to go for your first few prints. You shouldn't get any under extrusion or clicking noises, assuming that your temperatures are set right. Also, another thing you'll have to do before you start printing is to lube up and oil all of your linear bearings. You can use a I recommend some sort of sewing machine oil, or maybe an RC bearing oil works well. Something that's very thin and a little bit sticky. That way it will hold to the bearings inside and allow free, smooth movement. It's nice to have a syringe applicator. That way you can get right in there and oil straight into your bearings. It's probably a good idea to oil your bearings before you put them on your rods. That way you can get right into the bearings and deposit your oil directly onto the ball bearings inside the linear bearings. If you didn't do that in your build, don't stress too much. You can just apply it to the rod. Just run a thin line up the rod, underneath it, and run the bearings through it. It will pick up the oil and deposit it inside. Not a problem. This will alleviate catching and vibrations within the bearings and free movement. So, how are we going to rate this printer? Well, I'll break it down into a few sections so that we can standardize our 3D printer reviews from here on in. Each section gets a rating out of 10, and then an average of all the sections will give us the final score of the product. Now the sections are: Section 1, shipping and packaging of the product. Was the product received quickly after payment, and was it all in good condition upon arrival? Section 2, quality of parts and product. Is everything accurately made, and does it all fit together and work well? Section 3, quality of service. Was the service provided effective, efficient, and accurate? Value for money is Section 4. We rate the value for money compared to similar products within a similar price range. And Section 5 is your overall experience from start to finish. How it was, how it went, how you felt, and everything in between. Okay, so for Section 1, shipping and packaging. This is a bit of a sore subject within NerdSpark. I was asked by Geeetech to only review the product. Only the product. And not the whole package as if I purchased it. Having said this, I cannot ignore the state that this printer arrived in. There was no padding between parts. Each part was not separately packaged. The box was so damaged that parts were lost in transit. The glass print bed, this particular one was replaced with one I already had, was broken and damaged. The Xaxis drive and guide rods were slightly bent. However, I did agree to receive and review a used printer. So because of this, I can't give packaging and shipping a score in this particular review. Section 2, quality of parts and product. I would say the parts are of good quality, fairly accurately produced. They all look well made and generally fit together with no issues. Some are tight, but that's okay because we want tight fitting product. We don't want anything loose and wobbly. There are some issues with the design of this printer though, as discussed previously. As well as the manufacturer only included, for some reason, 3 Y-axis linear bearings. Just hold this back for you guys so you can have a quick look without ripping it to bits. I don't know if you can see there that there's only 3 linear bearings, 2 on one side and 1 on the other. My CTC clone came with 4. I'm not sure how much cost that would benefit you guys. I don't really see too much of a problem with it, but I'm not too sure why they thought that might be a good idea. This is not a common setup. Commonly you get the 4 bearings, 2 on each side for each guide rod. Furthermore, and probably the most important problem I see with the design of this machine, is that the manufacturer seems to have sacrificed structural stability for reducing costs for the printer in this range. Why are we missing structural support in the y-axis? When this is printing, it's going to wobble side to side because of the weight of the extruder. I don't understand, but it is what it is. So for those reasons, I'm going to give it a 7 out of 10. Section 3, quality of service. I didn't have to deal with any online services or checkouts. I only dealt with their Geeetech rep, and he was friendly and knowledgeable to a degree. I did have a look online at the Amazon checkout features. It seems simple and easy to use. Geeetech do offer a bunch of add-on extras at checkout, like the 3D touch leveler, Wi-Fi module, that kind of thing. So for that, I'm going to give it a 6 out of 10. Section 4, value for money. This is an average printer at a more than average price, and there's a bit of a paradox. We've got good quality alloy couplers down here, and then we've only got 3 linear bearings on the print bed. You have a quality ramps controller, and then that's countered by poor structural integrity. A quality extruder head, but no layer cooling fan. And most importantly, it can potentially be dangerous to build this machine. Someone tried to put together a low-cost printer, but in my opinion they made all the wrong compromises in all the wrong places. However, most of these problems can be overcome by simple, easy, readily available printable upgrades. Links are in the description. Sadly though, the only thing that can't be fixed, and arguably the most important thing that can't be fixed, is the structural problems. Why they decided not to make that front face as one single piece. So for these reasons, I'm scoring the value for money 4 out of 10. Section 5, overall experience. The overall experience was a little bit disappointing. I was not expecting to get a damaged product for review, even though I was aware that it was a used product. The service for the product was okay, and I did agree to receive a used product, so for that I'm going to give it an average score of 5 out of 10. So, what's our average score for this machine? Well, our average score is an average of 5.5, which is just over an average, 10 being the best and 1 being the worst. I'm sure if I received a new non-used product purchased direct from the store, I would have been able to give this product a much better score. But as it stands, I have to review it as I have it. The product itself is of good quality and prints after the box after a bit of tinkering and assembly. No mods are needed, don't need the cooling fan, don't need these Xaxis mods. You can print. I've got some prints here. We did these straight out of the box. I could have tinkered with the settings a little bit more to get these to print with better layer adhesion. I'd have to live with the Xaxis wobble until I upgraded the parts. Not a big deal. This product also has a very good selection of extra add-ons. The 3D Touch Auto Leveler is probably a good idea if you don't want to spend 15-20 minutes leveling the bed with a piece of paper, sliding it between the print bed and the nozzle, which is great fun. It would have been good to review this product as new, but it is what it is. Would I recommend this product to someone that's new to 3D printing? Not a chance in hell. This product is not for newcomers to 3D printing. It is extremely dangerous. I cannot stress this enough. It is dangerous. You can electrocute yourself on 240 volts and kill yourself. If you know someone that has an understanding of these FDM printers, of this i3 style design, then sure, give it a go. You've got somebody to help you. If you're already experienced, then yeah, it's probably a decent machine for its price. A good extra machine to get dual printing going. But if you're entering into this hobby without any experience, this is not the printer for you. Guys, I hope this review has helped. It's been a long road to get here. We have had arguments here at NerdSpark in the studio over what we should and shouldn't include in this review. We're not getting paid by Geeetech. They have not paid us, nor will we ever accept to do a review on a paid basis. We are independent and subjectively review our products as if we are a customer purchasing it. The issues with this printer put me off as an experienced 3D printer builder quite significantly. One of the other guys here at NerdSpark Studios is severely put off 3D printing because of this machine. I feel that if this machine was sent to me as a new, out of the factory machine, straight from Geeetech, our experience with this machine would have been significantly different. Our review standard would have been significantly different. But as it stands, we must review on what we receive. We refuse to give biased reviews based on the fact that Geeetech said we could keep this printer, so long as we give you guys the truth. And the truth is that this was disappointing. So, I hope this helped you guys out in deciding to buy a printer. With a 5.5, barely above average rating, I probably wouldn't buy this. You can probably buy a better printer in this range for with a better result. Geeetech, in fact, offers such printers. For an extra $100, you can get a plexi or even an aluminium design, which has none of these flaws that are on this particular design. So I guess the moral of the story is, don't go the cheapest you can find, because it's generally going to be more hassle in the end. Purchasing of replacement parts, such and so forth, you probably end up spending that extra $100 that you could have spent earlier, later on. Thanks very much for watching, guys. Please don't forget to subscribe, like and follow. Make sure you click that little bell icon so you get notifications when we upload new videos. Until next time, enjoy.
Thanks for watching.